Hello everyone. This video is on the Knewton Alta assignment for section 12.1 part 2 called Ellipses Not Centered at the Origin. Alright, so in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same and the structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Now the assignment page, you should have the title, the mastery bar, right, telling you how far along you've gotten, the objectives. Looks like there are 3 objectives for this assignment. Under the current objective, you should see a question related to that objective. At the bottom of each question, there should be a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. Alright, this is for instructors only. But you will have this more instruction button. If you're ever struggling with a topic or a question, try clicking on this and it'll take you to a page with some further reading or videos to study, and then you'll be given questions related to that instruction, and completing those questions is another way to progress through the assignment. Alright. So the first objective I'm looking at is identify key points and axes of ellipses not centered at the origin. Alright, so in section 12.1 part 1, I went over a lot of stuff about ellipses that were centered at the origin. And I've got those pages written out right here actually. Right, on ellipses that are centered at the origin. Right. And you had a major axis, a minor axis, vertices at the ends of the major axis, co-vertices at the ends of the minor axis. You have these 2 points called foci that were on the major axis. You had this lowercase a number, which was the distance from the center of the ellipse to a vertex. Lowercase b, the distance from the center to a co-vertex. And lowercase c was the distance from the center to a focus. Alright, I wrote out all this stuff, and here were the equations of an ellipse in standard form centered at the origin. It was x squared over some number plus y squared over some number equals 1. In either case, whether the major axis was horizontal or vertical. The only difference between these, where the graph is centered at the origin, and ones where it's not centered at the origin, is there's a shift in the x and y. The only thing that changes is the x squared, y squared. And I'll show you what that change is. Okay, so for an ellipse, this is the standard form. That's a P, sorry. Say we want an ellipse centered at the point h, comma, k. Kind of like oops, sorry. That's off the screen. I apologize. Ellipse centered at the point h, comma, k. Right. And just like back in section 12.0, that assignment on circles, right, we dealt with the circles having center of hk. It's very similar here. So instead of x squared, we're going to have the quantity x minus h squared, and then divided by some number squared. So say a squared plus, and then instead of y squared, we now have the quantity y minus k squared over some number squared, some b squared. equals 1. Right. So this has a center at HK, and then remember the value of A. Again, I wrote all this stuff out in the previous page, what I just showed you a minute ago. Little a was the distance from the center to a vertex, right, the end of the major axis. Little b represents the distance from the center to a co-vertex, right, one of the ends of the minor axis. And then little c was not on the formula, but we can find it using a and b. Little c squared, remember, was little a squared minus little b squared, right? And then little c told us how to get from the center to the focus, right? And to both foci, right? And the foci were both on the major axis. Now remember, if the larger, a is greater than b here, right? If the larger denominator is under the x term, that means the major axis is horizontal. The major axis will be parallel to the x-axis. Right, so it'll be an ellipse that's longer horizontally than it is vertically. Right. Now the other way around is if you just switch a and b here, we have the quantity x minus h squared divided by b squared, right, the smaller denominator, plus y minus k squared divided by a squared, the larger denominator, equals 1. If this is the case, if the larger denominator is under the y term, then the major axis will be vertical or parallel to the y-axis. Right, so in that case, you're going to have an ellipse that's longer vertically than it is horizontally, right? It's taller than it is wide. Right. And again, in either case, we can find c, that distance from the center to the foci, using this formula here, right? This relationship between c, a, and b. C squared equals a squared minus b squared. So not much changing from section 12.1 part 1. We just have these little shifts, right or left h units and then up or down k units by replacing x with x minus h and y with y minus k. All right. So the first example we're given, the first equation, is the following. I have the quantity, x plus 6 squared divided by 25 plus the quantity y plus 5 squared divided by 64 equals 1. Now if I want to write this perfectly in that form, I mean, this is in standard form. You have an x squared term plus a y squared term fraction equals 1. Right? This is in standard form. But if I want to write it so I can identify h, k, a, and b, I'll do it this. Well, x plus 6 is the same thing as x minus negative 6. Right, so negative 6, and then you got squared, right? But so negative 6 is the value of h. That's going to be the x coordinate of the center. It's the number that's being subtracted from x in that square. A quick way to think about that too is just think about what would you have to replace x with to make this 0. Right? Negative 6 plus 6 would be 0. So negative 6 for the x coordinate of the center. 25 is 5 squared. And that's the smaller of the two denominators, right? So the value of b, the smaller one, right? There's a and b. b is 5, right? So b is 5. If b squared is 25. plus, and then we have y plus 5 squared. That's the same thing as y minus negative 5 squared, right? So the value of k, that y value of the vertex, of the center, sorry, is negative 5. Right? And again, you can think of this pretty easily in another way. Just think of the y value you'd have to plug in to get 0 here. Right? If you made these 0, that'll give you the x and y coordinate of the center of the ellipse. And then 64 is just, 8 squared. Right, so the value of a, and that's the larger of the two, right? That's the larger of the two, so the value of a is 8. And then we have equals 1. Alright, so you don't have to do what I just did, but if you want to put it in perfectly that standard form so you can easily identify h and k and a and b, go ahead. But so the center, like I said, the center of this vertex, of this ellipse, the center of this ellipse has an x coordinate of negative 6 and a y coordinate of negative 5. Right. And I'll start plotting this stuff. Right here, it's going to be a tiny plot, but I'll go to that desmos.com free online graphing calculator in a minute, and we'll look at a much better picture. So here's negative 6 for the x, and then negative 5 for y. And now this point, I'm plotting it, but it's not actually a point on the ellipse. You may recall this from, again, section 12.1, part 1. The center and the foci are not on the ellipse. They don't actually satisfy the equation. Right, if I were to plug these two numbers in for x and y, you'd get 0 plus 0 equals 1. That's not true. Right? So this is just a guide, right? Just the center. Now, we said earlier a was 8. Right, the value of a, the square root of the denominator, the larger denominator, was 8. And notice it's under the y term. So that means the major axis is vertical. This will be an ellipse that's taller vertically than it is horizontally. And a is 8. Right, so all I need to do is add and subtract 8 to the y coordinate, plus or minus 8 to y coordinate of the center. Or go from the center, go up 8 to negative 6, 3. And I'll actually label this. This would be a vertex. Alright, negative 6, 3. And I'll start doing this over here. The vertices. One of them is at negative 6, 3. And you can check that out. Plug in negative 6 for x. And plug in 3 for y. And you'd get 0 plus 64 over 64 is 1. That's true. 0 plus 1 equals 1. So I'm making that like a bigger point. That's actually a solution. So I went up 8 and then down 8 to minus 13 here on the y-axis. And here's another vertex at negative 6, negative 13. That would be the other vertex, negative 6, negative 13. Right, so there are the vertices, the ends of the major axis. And then the co-vertices, will be the ends of the minor axis, which will be horizontal, right? If the major axis is vertical, the minor axis will be horizontal, and we're going to find the co-vertices. Right, and we saw that b was 5. So what I'm going to do is I'm going to plus or minus 5. I'm going to add and subtract 5 to the x coordinate this time, right? Because again, the minor axis should be horizontal, to the x coordinate of the center. Or go from the center to the right 5 units. So here would be the point negative 1, negative 5, right? Negative 1, negative 5 would be a co-vertex. And once again, you can check this out. Replace x with negative 1 and y with negative 5 back in this equation, and you'll get 1 plus 0 equals 1. It works. And then from the center, go left 5 units to negative 11 on the x-axis. There's negative 11, negative 5. Right, there's another co-vertex, another end of the minor axis. And once you have the vertices and the co-vertices, you should be able to make a rough sketch of the ellipse. Just drawing an ellipse that touches all the points, make it look curvy, right? Make it look like an oval. All right, now for the foci. All right, now the foci, remember, will be on the major axis. So here's the major axis that I just put in dotted here, going up and down. The foci will be on that segment inside the ellipse. Now to find the foci, I need to find that little c, right? And there was that relationship, little c squared equals a squared minus b squared, which in this case is just the difference in these denominators, 64 minus 25. Alright, so 39. Alright, 64 minus 25 is 39. And then c would be the square root of 39, which is between 5 and 6 units. So if I go from the center, go up, between 5 and 6 units, so go up 1, 2, 3, 4, 5 and 6. So somewhere in here between 0 and 1 will be the y-coordinate of the focus. So one of the foci is going to be at -6 still for the x-coordinate, and then I'm just adding square root of 39 to the y-coordinate of the center, so -5 plus square root of 39. And then I'd also throw in minus there, right? Throw a minus in there, because if I go -5 minus the square root of 39, I'm 1, 2, 3, 4, 5, 6, somewhere in between -10 and -11 for the y-coordinate of this other focus. So I'll call this focus 2. So here's the two foci, -6, comma, -5 plus the square root of 39, and then from the center again, -6, comma, -5 minus the square root of 39. That's where the two foci will be. Right? We're going to be asked for one of these pairs of points in all of our problems here. But they want the co-vertices, right? So this -1, -5, and -11, -5. Now you can look at a better picture too by going to that Desmos website, desmos.com, free online graphing calculator. I'm just going to enter the equation they gave me. X plus 6 squared divided by 25 plus y plus 5 squared divided by 64 equals 1. Alright, and the nice thing about Desmos, you click on the curve or click on the equation, and it throws out these. You can see the vertices, the tops of hills, bottoms of valleys, so that's why they correspond to the vertices. But -6, 3, -6, -13. You see the x-intercepts, but we don't need the x-intercepts, right? We weren't asked for those. And then you see the ends here. There's -1, -5, like I had, and then the other side, -11, -5, right? Those are the co-vertices, and that's what we're asked for. -1, -5. Oh, they're asking for vertices and co-vertices. So we said the vertices were at -6, 3, -6, -13. The co-vertices at -1, -5, and -11, -5. That's this option here. Alright. Now after you submit an answer, it'll tell you, if you're right or wrong, and then give you some sort of answer explanation. Please read through the answer explanations just to make sure you understand why something was right or wrong, and hopefully you can learn from your mistakes for future questions. Alright, so now we're in this objective, write the equation in standard form of an ellipse not centered at the origin. Alright, so here they're giving me some vertices and the foci of the ellipse, and we're asked to write the equation of this ellipse in standard form. Alright, so I'll write this information out. Maybe even draw a little picture. So the vertices are at 3, -19, and 3, 7. And the foci, which are also going to be on the major axis. Remember, the vertices are the ends of the major axis, and the foci are on the major axis inside the ellipse. So they're 3, negative 12, and 3, 0. And I'll draw this, again, a very rough sketch, so 3, let's say this is 3 for the x here, and then negative 19 for the y. There's a vertex, and 3, 7. There's another vertex. 3, 0 is a focus, so I'll actually put F1 next to that, and 3, negative 12 is another focus. So hopefully you see that the major axis must be vertical. And that means you're trying to fill in the following equation. X minus h squared over b squared, right? The smaller denominator is going to be under the x, plus, and then y minus k squared over a squared, right? The larger denominator is going to be under the y if the major axis is vertical, and then you have equals 1. We're trying to fill in h, k, a, and b. Alright, well the center should be easy to find. If you know the two vertices, or even the two foci, the center is the midpoint of these 2 points. Now I hope you know how to find midpoint. You just take the average of the x-coordinates, which is 3 obviously, and then the average of the y-coordinates. Well, negative 19 plus 7 is negative 12, divided by 2 is negative 6. So there's your h and k. There's 3, negative 6, there's going to be the center. But again, all on the major axis here right now. Okay, now we can find little a easy enough. We know a vertex. Remember, little a, that's the distance from the center to a vertex. So that's 13 units, right? If you go from the center to this vertex or from the center to the other vertex, that's 13 units. From 7 to negative 6 or negative 6 to negative 19. So that's a, that's little a, right? 13, meaning that a squared, right, the denominator under the y term, is going to be 169, right? 13 squared. Now I just need to figure out the b, right? I know h is 3 and k is negative 6. I know a is 13, or a squared is 169. I just need to know b. Now, we don't know b from the picture. Right? From the information they gave us, we know that little c, right, the distance from the center to a focus is little c, which is 6 units here. Right? From the center to either focus is 6 units. Now to find little b, I must use that one relationship I've been writing. C squared is equal to a squared minus b squared, right? And then we're going to solve for b. In other words, b squared is a squared minus c squared. Right, if you just solve for b squared there. And a squared we know is going to be 169, and c squared is going to be 6 squared, that's 36. And 169 minus 36 would be 133. Alright, and there's the value of b squared. So now I have b squared, I have a squared, I have h and k. I can fill in the equation of the ellipse they want. Now b would be the square root of 133, so if you go from the center right square root of 133 and left square root of 133, you'll have the co-vertices, but we're not asked for any of that. The equation of the ellipse they want us to draw is the following. X minus 3 squared, that's the x value of the center, divided by b squared is 133. And we saw that here. Plus, and then y minus k, y minus negative 6, right, which would be y plus 6 squared divided by a squared, we know is going to be 169, equals 1. this is the equation they want. All right. That's the equation with the center at 3, -6. And the foci will be -12, 3, 0. The vertices will be at 3, -19, 3, 7. And we're not worried about the co-vertices, but you could draw the co-vertices if you wanted. Alright, so looking through these options, that's the very first one. That's the very first one. Alright, great. Okay. Alright, now here we're back to the given an equation, identify some key points. They're asking for the vertices and co-vertices. Alright, so once again, I'll write this equation out, maybe even draw it. So we have the quantity x minus 6 squared divided by 100 plus y plus 3 squared divided by 16 equals 1. Right? This is an equation of an ellipse in standard form. Now the center should be simple enough, right? Just what makes this 0 would be 6 for x. What makes this 0 would be -3 for y. There's your h and k. And then the larger denominator is under the x, right? So a squared is 100, meaning that a is 10. And since it's under the x, that means we're going to go right and left 10 units. Now, so the vertices are, 6 plus or minus 10, comma, -3. You just take the coordinates of the center, and to move right and left 10 units to get to the vertices, we add 10 and subtract 10 from the x coordinate. So one of them is 16, -3, and the other one is 6 minus 10, or -4, -3. There are the vertices. All right. Then the smaller denominator is under the y. Right? B squared is 16. So b is 4, and we're going to go, b equals 4. And we're going to go up and down 4 units from the center to get to the ends of the minor axis, right, to get to these co-vertices. So the co-vertices, again, you just take the coordinates of the center, 6, -3, and you're going to add and subtract 4 to the y coordinate. So one of them is at 6, 1, and the other one's at 6, -7. And there are the co-vertices. And again, you can draw it by hand if you want. I'll go to the calculator. We had x minus 6 squared divided by 100. And then y plus 3 squared divided by 16. There you go. And scoot over here so you can see it, and then you see one of them is at 6, 1. That's a co-vertex. The other co-vertex is at 6, -7. And then see over here there's 16, -3. That was one of the vertices. And -4, -3, the other vertex that I did write out on paper. Wonderful. And pay attention to what's what. Remember, vertices are the end of the major axis. Co-vertices are the end of the minor axis. So you gotta make sure you're putting things in the proper place. So 16, -3 is one of the vertices. And then -4, -3 for the other. And co-vertices 6, 1. And 6, -7. That should be good. And again, we saw a graph, we saw a picture of it. Great. Alright, so back to this where we're given some information. Now here we're given the vertices and co-vertices. Alright, So again, I'll write this information out now. So we don't need to use that whole c squared equals a squared minus b squared, because we'll know a and b from the vertices and covertices. We'll know those right away. So this time the vertices are the points -3, 1, and 9, 1. And the co-vertices, right, the ends of the minor axis, are at 3, 0 and 3, 2. And if you want to draw this stuff, go ahead. You know, -3, 1 vertex, 9, 1 another vertex. So that means the the major axis is horizontal. Right, so the major axis is horizontal. So when I'm writing the equation out, it's going to look like this: x minus h squared divided by, now this time the a squared is under the x. The larger denominator will be under the x term, plus y minus k squared over b squared equals 1. And the co-vertices are at 3, 0 and 3, 2. Alright, so there, and then you can actually draw the whole ellipse in if you want. You know, if you know the vertices and co-vertices, you can draw the ellipse in, but the center is going to be the midpoint of the vertices, or the midpoint of the co-vertices, which will be at 3, 1. I hope you can see that. The center has to be at 3, 1. So there's h and k, right, 3 and 1. So we got x minus 3 squared over some number plus y minus 1 squared over some number equals 1. I'm just filling in the formula as I go. Alright, and then the distance from the center to a vertex is, you know, from here 3 to 9, that's 6 units. That's a. Alright. So a is 6, meaning that a squared is 36. So there's going to be 36 under the x term. And then the value of b is 1 unit. Right, the distance from the vertex to a co-vertex. Sorry, from the center to a co-vertex. It's only 1 unit. So b is 1, meaning that there's going to be 1 under this other term, which you don't really need to have divided by 1. You can just have y minus 1 squared. But there's the equation of our particular ellipse in standard form. And you can look at a graph if you want, just to make sure. You know, go to Desmos or something. But and looking through these, the only one that matches is this fifth one here. Nope. This one. This third one. X minus 3 squared over 36. That was 6 squared. Plus y minus 1 squared over 1 equals 1. Great. Alright. Next. Alright, so again we're asked now I've been doing this. And here's a nice thing, we can move some points around. So I'll just talk this one out. Again, you can graph it on Desmos, you can do it by hand. I've been doing a few of these by hand already. You know, the x coordinate of the center must be -5, so I'm going to move the center over here to -5, and then the y coordinate would be at -6. Right, so the center is going to be at -5, -6. Just make sure that that's labeled properly. -5, -6 for the center. And then under the x plus 15, you know, under the x term, there's a 16, which is 4 squared. So the value of 4, I'm going to move right or left 4 units for points on the ellipse. So here's -5, -6. You know, if I move to the right 4, 1, 2, 3, 4, there's -1, -6. On the other side should be, you know, -9, -6. And then under the y term, there's a denominator of 1. Square root of that's 1. Just move up or down 1. So the co-vertices here should just be 1 unit above the center and 1 unit below the center. So at -5, -5 here. And there's a graph of the ellipse from the equation we were given. You just move the center around, move one of the vertices to the proper place, move one of the co-vertices to the proper place. Pardon me. Okay. Alright, so another one like this, where again the equation is given to us in standard form already. So identifying the center should be simple, and then knowing how far right or left and up or down the vertices or co-vertices should also be pretty simple, in my opinion. Notice it's just x squared, so the x coordinate for the center is 0, h is 0. And then you got y minus 4 squared, so 4 is the y coordinate of the center, so 0, 4 for the center. Then under the x, it's a denominator of 1, so the co-vertices should be 1 unit right and left of the center. Under the y, they have 4, which is 2 squared, so the vertices should be 2 units above and below. So if I have 0, 4 here, 0, 6 would actually be a point on the graph, and you can plug these points in. Plug in 0 for x and 6 for y. Plug in 1 for x and 4 for y, and you'll see they make this true. The center doesn't work. Remember, the center doesn't work. It's the points on the ellipse that actually should make the equation work, and that should be good. Alright. Okay, we're asked to find the foci this time. Alright, so again, I'll write this out. And you should, after some practice, should be able to find all these points, the vertices, the co-vertices, and the foci without even graphing. Alright. Alright, so here's the equation we're given. It's already in that standard form. X minus 1 squared divided by 36 plus y plus 2 squared divided by 16 equals 1. And right away I can tell you that this has a major axis that is horizontal. And it's going to be longer horizontally than it is vertically, because the larger denominator is under the x term. Okay. Now the center is 1 for x, negative 2 for y. And now if I want to find the foci, right, like they're asking me for, I just need to find the value of c, that lowercase c number. Remember, c squared is a squared minus b squared for an ellipse. The larger denominator is a squared, the smaller denominator is b squared. So this is 36 minus 16, which is 20. So c is the square root of 20, which can be reduced to 2 times the square root of 5. Hopefully, simplify radicals should be simple enough for you. And then again, the major axis should be horizontal. So from the center, I should be going right and left 2 root 5, and that'll take me to the foci of this ellipse. So the foci are, you just take the coordinates of the center, and you're just going to add and subtract 2 times the square root of 5 to the x value. That'll move it right and left. That'll be on the horizontal major axis. So one of them is 1 plus 2 root 5 comma negative 2. The other one's 1 minus 2 root 5 comma negative 2. Right. So 1 plus the square, 2 times the square root of 5. Get out of there, comma negative 2. And then I'm just going to copy and paste this in the other box. And replace this plus with a minus. There you go. And that should be good. And like I said, with enough practice, hopefully you'll be able to do this too, where you can find these points, vertices, co-vertices, foci, without actually graphing. Alright, so let's do that again. Very similar. But this time it's just the vertices and co-vertices, so I'm just going to talk this one out. The center will be at 4 for x, negative 6 for y. Alright, so 4 for the x coordinate, negative 6 for the y coordinate of the center. underneath the x you got 25, which is 5 squared. So the value of a is 5, that's the larger of the two. So I'm going to add 5 and subtract 5 to the x coordinate of the center. So you have 4 plus 5, 4 minus 5, comma, negative 6. Right? Now 4 plus 5 would be 9. So 9 comma negative 6 will be one of the vertices. And then 4 minus 5 is negative 1. So negative 1 comma negative 6 will be the other vertex. Alright, then for the co-vertices, I go from the center, I'm going to go up and down. You know, the minor axis would be vertical if the major axis was horizontal here. So again, 4, negative 6, but then I'm going to add and subtract 2 to the y-coordinate. Negative 6 plus 2, negative 6 minus 2, with an x-coordinate of 4 both times. So 4 comma, negative 6 plus 2 is negative 4. So 4, negative 4 will be a co-vertex. And then 4 comma, and then negative 6 minus 2 will be negative 8. So 4, negative 8 will be another co-vertex. And once again, if you want to go to the Desmos site, I'll leave that to you to check if you want. Graph this equation. You'll see that these are the ends of the major axis, these are the ends of the minor axis. Simple enough. Alright. Moving on. Alright, so here we're given the vertices and foci again. Asked to write an equation. So remember, I just need h and k, and then a squared and b squared. Alright, so let me write this one out again. And I might just not write the last one for this objective, but so the vertices are at negative 6, 2 and 14, 2. The foci are at negative 3, 2 and 11, 2. And I hope just based on the way these are stated, you can tell that the major axis is horizontal without even graphing. Because, negative 6, 2 and 14, 2, they have the same y-coordinates, so you have to move left and right, to get from one point to the other. So yeah, horizontally. Now the center, remember the center is just going to be the midpoint of the vertices or the midpoint of the foci, which would be at 4, 2. Just the average of the x-coordinates, and then obviously the y-coordinates got to be 2. So we have x minus 4 squared over some number plus y minus 2 squared over some number equals 1. And the distance from this point to one of these points would be 10 units, so a equals 10. Alright, 4, 2 to 14, 2, I'd have to add 10 to the x-coordinate. So a squared is 100, and that's going to go under the x term because the major axis is horizontal. And then the value of c, 4, 2 to 11, 2 would be 7 units. And remember, b squared is going to be a squared minus c squared. And so b squared is 100 minus 49, which is 51. That's going to go under the other term. Right, b squared is 51. And there you go. This is what they're asking us for. Right? The equation of that ellipse with those vertices, those foci, centered at 4, 2 and in standard form. So I'll type this out. We have the quantity x minus 4 squared divided by 100 plus the quantity y minus 2 squared divided by 51 equals 1. And that should be good. Great. Alright, looks like one more of these from that same objective. Alright, so again, now this time the vertices have the same x-coordinate. So you have to move up and down to get from one point to the other here, these two vertices. So the larger denominator will be under the y term. The major axis will be vertical. the center will be at -6, -3. Alright, -6, -3. So I'll have some quantity with x plus 6 squared plus, and then some quantity with y plus 3 squared, right? When h is -6, k is -3 equals 1. I just need to know the denominators. Now the distance from -6, -3 to say -6, -13 is 10 units. So a is 10, meaning that the y term is going to have 100 for the denominator, 10 squared. And then the distance from -6, -3 to -6, -4 is 1 unit, so c is 1. The distance to a focus is 1 unit from the center. And if you subtract that from 100, that's 99. A squared minus c squared would be 99, and that would be b squared, and that's going to be the denominator under the x term. So x plus 6 squared over 99 plus y plus 3 squared over 100 equals 1. Alright. Great, and again, you can put up graphs if you want to do things by hand. I did a few of these examples by hand already, so just wanted to kind of talk that one out. Alright, then we're just graphing. Again, move the center around, move the vertices and co-vertices around. So here you have 0 for x, -5 for y would be the center. So 0 for x, -5 for y. Let's make sure it's in the proper place. The larger denominator is under the y, right? So the major axis is going to be vertical, and it's 9, which is 3 squared. So from the center I go up 3 units. 1, 2, 3, and there's a vertex right there, 0, -2. It's perfect. It's already where it needs to be. Under the x term, there's a 4, which is 2 squared. So from the center, I go to the right 2 units. So this point needs to be here, and 2, -5 would also be a solution to this equation. That's a co-vertex. And then just double check, when you plot the points, make sure that the points that are actually on the ellipse actually satisfy the equation, and they should. Great. I should have just one more of those based on my progress. Alright, so x plus 3 squared over 25 plus y minus 3 squared over 4 equals 1. The x coordinate of the center will be -3. The y coordinate of the center will be +3. So I move the center till it's at -3, 3. The major axis is going to be horizontal here because the larger denominator is under the x, and that's 25, which is 5 squared. Alright, so I need to the right of the vertex, I need to go 5 units, which would be at 2, 3. That's 5 units to the right of -3, 3. There's a vertex, and again, you can plug in 2 for x and 3 for y just to make sure that it makes the equation true. And then under the y term, you got 4, which is 2 squared. So I need to go up 2 and down 2 for the co-vertices. If I go up 2, that'd be -3, 5. That's a co-vertex. And again, check it out. Plug in -3 for x and 5 for y, and it should make this equation true. And there's a graph of the ellipse, described by that equation. Alright, great. Alright, and that should be it for this preview version of this assignment. Like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are the same, the structure is similar. So I'm hoping that watching me go through these examples here help you out in some way when you work on the assignment on your own. And thank you very much for watching.